Hi everyone, welcome to this Packet Tracer. Observe traffic flow in a routed network. Objectives Part 1. Observe traffic flow in a unrouted LAN. Part 2. Configure the network to route between LANs. And Part 3. Observe traffic flow in the router network. Background scenario: the company that you work for has been asked to propose a new network design for, is a startup company that has recently experienced success with their products offerings. They will be expanding, and their network will need to grow with them. Currently, the network is configured with a single IP network for hosts in all departments. This design has become inefficient and network delays are becoming increasingly noticeable. You have been asked to help prepare the proposal with the sales team. The sales team will propose a solution in which network efficiency is enhanced by implementing routing between separate department networks. You are working on a demonstration of how having multiple routers network in a business can improve network efficiency. Follow the instruction to go through the demonstration to help process a new network to this enterprise. Instructions Part 1. Observe traffic flow in an unrouted LAN. The company network consists of about 150 devices that are connected to the LAN. The LAN is configured on a single IPv4 network. Hosts in different departments are connected to switches, which are then connected to the edge router. The router only routes traffic between the LAN and the Internet, represented by the ISP cloud. Because only one IP network is used in the LAN, all departments are on the same network. The packet tracer topology is simplified. It only shows some of the departments and hosts. Assume that the behavior that you will demonstrate is happening at far greater scale than what's shown in the PT network. In this part, you will use Packet Tracer simulation mode to observe how traffic flows through an unrouted LANs. Step 1. Clear the ARP cache on host sales 1. Hover your mouse over the sales 1 host to see its IP addresses, make note of it. Click Sales 1 desktop tab. Okay, wait a minute. Click Sales 1. Okay. Sales 1. Okay. Desktop. Command prompt. And then enter the ARPA command. Okay. ARP. Sorry. A. There shall be no MAC address in the ARP cache. If there are entries in the ARP cache, use the ARPD command to delete them. Okay, so with the command. Okay, step 2, observe traffic flow in the network. Okay, there should be no MAC address in the ARP cache. If there are entries in the ARP, use the ARP command to delete them. Okay, step 2, observe traffic flow in the network. Click the Simulation Mode button in the lower right-hand corner of the PT window to switch from real-time to simulation mode. Okay, open the command prompt for Sales2 and then enter the ping command followed by the IP address for Sales1. Use the capture. Okay, use the capture then forward button, the triangle pointing to the right with a vertical bar attached in the play controls of the simulation panel. To ping execute the ping command, you will see a colored envelope icon appear next to Sales2. They represent a PDU. Click the Capture then Forward button to move the PDU to the first device on its path to the destination device. Click the PDU envelope to inspect the content. What are the source and destination MAC and IP address for the frame and packet? Why is the destination MAC address the broadcast address? Okay, open Sales2, desktop, command prompt, and enter a ping to Sales1, close, okay, okay. We can see the packet travel from Sales2 to Sales1. Okay, very well. Okay, the next point is what are the source and destination MAC and IP address for the frame and packet? Why is the destination MAC address the broadcast address? In the first case, the packet is sent from Sales2 to Sales1, but this packet is sent to the other's host in the network, and later only the Sales1 responds to the Sales2. Okay, and say why is the destination MAC address the broadcast address? Advance the PDUs through the network until a new PDU different color is created at Sales2, which host and other types of device need to process the ERP request packets. What is the impact of this on efficient operation of the network as it is currently configured? No, and a new PDU with a different color has appeared at Sales2. Click the new PDU and inspect its content. Look at the outbound PDU details, what type of PDU is, and return to real mode. Okay, this is why in the first step the envelope is a color green and later is a color red, how in this case. And part 2, reconfigure the network to route between LANs. In this part, you will demonstrate the benefits of routing between departments network. First, you will cable each network switch to connect directly to a router interface. Then, you will reconfigure the host to receive address on two new IP networks that are created by the router. Okay, wait a moment, only stop real time. Okay. Step 1, change device connection. The three switches are connected to each other with Cooper string trouble cable. Step A, for the cable that connects the accounting switch with finance switch, click the green triangle on the accounting switch side of the link. Okay, click the green triangle on the accounting switch side of the link. Okay, in account, drag the end of the cable to the edge router and connect the cable to port Gigabit Ethernet 1/0. Okay, here. And repeat this step for the link between finance and sales. Connect the available Gigabit Ethernet port. Okay. Step 2. Configure the host with address on the new LANs. Each interface of the edge router was previously configured to put each department on its own IPv4 network. The host will receive their new IP address from the router. However, it will take time for the host on the finance and sales network to receive their new IP addresses. The host on the accounting network will remain on this address. Okay, the host on the accounting network will rename on this. Okay. To speed up to the process of getting new IP addresses, open the command prompt on each of the four devices in the finance and sales network. Enter the ipconfig/renew command. This will force the host to request a new IP address from the DHCP server that is running on the edge router. You should see confirmation of new IP addressing. What IPv4 network is assigned to the finance network? What IPv4 network is assigned to the sales network? Okay, first in finance, desktop, command prompt, and enter this command ipconfig okay slash is here. Okay, IP address in this case is this, and the file gateway is this subnet mask. Okay, close, and sales 1, enter slash sorry. Okay, well, and the stock command prompt. Okay, Okay. And what IP4 network is assigned to the finance network? Mm, okay, finance here and sales here. Okay, desktop IP configuration, desktop IP configuration. Okay, this is the part of the network portion 192.178.3 and 2 is the portion of the host. And the finance one is 192.178.2 to the portion of network. And the for gateway is different. Okay, well. And part 3, observe traffic flow in the router network. In this part, you will observe how traffic now flows through a router network. Step 1, ping sales 1 from sales 2. Return to the command prompt for sales 2 and verify that its ARP cache is empty. If it's not, delete any entries. Okay, command prompt. And what is the command? ARP slash sorry, no ARP entries found. Okay, and switch to simulation mode. Ping sales 1 from sales 2. Okay, ping to sales 1. And okay, we can see the packet. And okay, the color of envelope is green in this case. Okay, in this case, the take less time in send the packet because no across all the switches and all the hosts. Okay, and use the capture then forward button to step the PDUs through the network. Observe how the ARP request message flow through the network this time. Which device received the ARP broadcast this time? Only the host sales 1. And step 2, ping other host. Repeat this demo by pinging other hosts on the internet server. Observe the flow of the ARP request videos. What is the benefit? What is the benefit of using multiply IP for network of or subnetworks within our enterprise node. The network topology that is used in this activity is for demonstration purpose only. While it's possible that a real enterprise network could use a router in this way, there are more optimal topologies that achieve these results. You will learn more about other design approaches in late networking courses. Okay, once again, this one, sorry. Mm, and real-time simulation to a coating one desktop IP configuration here and send a pic. Okay, we can see the packet broadcast or the message broadcast. The color is changed. Okay, the switch forward the message to the switch. Well, this is all for this lab and go to the next is this. I close these activities. Yes. Okay. And this is the next activity. Packet tracer create a LAN. Addressing table, device, interface port, IPv4 address, and subnet mask. Objectives: connect network devices and host, configure devices with IPv4 addressing, verify the end device's configuration and connectivity, use networking commands to view host information. Background scenario: a new branch office is opening, and you have been asked to set up the LAN. The network devices are already set up, but you need to connect them and the host together. You also need to configure IP for addressing on the end devices and verify that they can reach local and remote resources. Instructions: Part 1: Connect network devices and host. Step 1: Power on the end devices and Office router. Click each device and open its physical tab. Okay. Note: there is no power switch on the switch model used in this activity. Okay, locate the power switch for each device in the physical device view window. Click the power switch to turn the device on. You should see a green light near the power switch to indicate that the device is powered on. Okay, connect. Okay, power on the end devices and Office router. And click each device and open its physical tab. Okay, and physical tab. Switch to physical workspace is locked by auto design for this activity. Okay, okay, okay. And step 2, connect the end devices. Use the table and instruction to connect the network device and host to create the physical network. Connection table. Device interface port. Connected to device connecting interface port. Okay. Office router gigabyte 0/0 connected to device ISP 1 connect interface port gigabyte 0/0. Okay, okay. And office router gigabyte 0/1 to switch gigabyte 0/1. And admin PC NIC switch fast Ethernet 0/1. And manage to the fast Ethernet 0/2 and printer to fast Ethernet 0/24. Okay, note: in the table above, interface designed with G are Gigabyte Ethernet interface. Interfaces that are designed with F are Fast Ethernet interface. Connect the network device according to the information in the connection table using Ethernet Cooper Sterling through cable. For the Internet to Office router connection, select the device and port from the drop-down menus that appear when you click the cloud with Connection tool select. Connect the two PCs and the printer to the Office switch according to the information in the connection table. Use copper string through cable. You should Okay, and you should see green link light on all connection after a brief delay. Part 2. Configure device with IPv4 addressing. Step 1. Configure the host with addressing information. The admin and managed PC should receive their addressing information from DHCP. The office router has been configured to supply IP addresses to hosts on the branch office LAN. Switch the PCs and go to the desktop tabs on each PC. Open the IP configuration application and configure the PCs to receive their IP addresses dynamically. Okay, well, okay. And printers and servers are often manually configured with addressing because other devices on the network are configured to access them using IP addresses. Manual configuration with a static address will ensure that the IP address of these devices do not change. Click the printer and open the config tab. Click the Fast Ethernet 0 interface in the left-hand pane. Enter the addressing information from the addressing table. Okay. Configure device. Sorry. Enter the addressing information from the addressing table. Okay, printer. Okay. And why do you think the IPv4 address are different, but the subnet mask and default gateways are the same? The printer does not require a default gateway because it will only be accepted by hosts on the local network. However, if you need to configure it with a default gateway, which value will the printer use? How can you determine this information? This from the other devices in the network? Okay. Well, close. Part 3. Verify the end device's connection and connectivity. Step 1. Verify connectivity between the two PCs. Go to the desktop of the PCs and check the IP addressing configuration. You should see that the PC have dynamically received IP addresses on the network. Okay. You should also see that they have received address for the default gateway and DNS server settings. From the command prompt on admin PC, ping the IP address of the printer. Repeat this process for the managed PC. You should see current full pings for each. This verifies that the PCs and the printer are powered on and correctly connected and addressed. Okay, admin command prompt and printer here. Okay, and well, ping. Okay. Okay, the connection is well. Go to manage PC. Okay, the connection is great. Okay, and step 2, verify connectivity to the internet. From the desktop of the PC, open the web browser. Enter the IP address of the internet server to display the web page. Repeat the process but connect using the URL of the server. Okay. From the desktop of the PCs, open the web browser, enter the IP address of the internet server to display the web page. And repeat the process but connect using the URL of the server. If you can connect by the IP address but not by the URL, what do you think is the cause of these problems? Okay, from this web browser, okay, okay, I can connect. Welcome to Cisco Packet Tracer, quick links, a small page, copyrights, image page, image. And manage PC2, go to web browser, manage www.cisco.pt. Okay, I can connect. Okay, part 4, use networking commands to view host information. The networking commands that are available from command prompt on PCs are very similar to those that are available in Windows. In this part of the activity, you will use ipconfig and tracer to learn more about the LAN. Step 1, use the ipconfig command. The ipconfig command displays details about the addressing that is configured on a host. Open a command prompt on one of the PCs and enter the ipconfig command and make note of the information that is returned. Now, enter the ipconfig all command. What additional information is displayed? Okay, command prompt, ipconfig, ipconfig. Okay, fast Ethernet 0 connection, Bluetooth connection, and ipconfig all display more information. DHCP server and more information. Okay. And step 2, use the tracer command. The tracer command uses ICMP Internet Control Message Protocol to return information about the router that are passed as packets go from the source PC to the destination. Trace to a remote destination by going to one of the PCs and entries tracer followed by the URL of the web server. How many routes are passed on the way to the destination? How are those routers identified? Where is the second router located? Okay, go ahead. Research to research. Okay, first 192.178.1.1. This is my host. Next is I don't know what is this this router. And how many routers are passed on the way to the destination? How are those routers identified? Where is the second router located? Reflection. Consider a small office that has a LAN similar to the one you have created here. What is the biggest facilities change in setting up the network in a new location? Okay, well, this is all for this. Uh, okay, config. I think this is from the router. Okay, and this is the website. Okay, see you in the next one. Thank you for watching. Bye.